We've now heard from Tesla some additional groundbreaking news about the Tesla bot Optimus. Elon has now confirmed that Optimus is now doing simple factory tasks, albeit within the lab. But then, he also said he expects to have a limited number of bots in the actual factory by the end of this year. And the most important news is that he expects to be able to sell externally to customers by the end of next year. Today we have Scott Walter joining us, and he'll be showing us videos of the factories in both Tesla's Giga Shanghai factory and BMW's factories to see what kind of tasks Elon is referring to. Scott is an aerospace engineer with a Ph.D. in mechanical engineering and has co-founded 2 robotics companies. Welcome, Scott.
Hello, Herbert.
Thank you very much for doing this. This is now the fun part. We're getting to the nitty gritty. So in the earnings call, Elon said this, that the robot is currently doing simple factory tasks, albeit in the lab. We do think we'll have limited numbers in factory by the end of this year, and we may be able to sell externally by the end of next year. What was your thoughts? Did you think that was good? Was that ahead of what you were thinking or behind what you were thinking?
I think it sounds pretty close to what Elon intimated earlier this year, that they were expecting something. Remember he used the term products a few times, and then them being able to start having products ready by early next year. So that's probably what he was thinking about already. And he already talked about it being in the factories. But I think the other thing I want to note is what question was that was actually asked in there? It
number
was
2.
It was number 2.
Yeah.
And remember, that gets voted by the shareholders, doesn't it?
Yeah.
On say. And so that was a very early question to be asked, which means anyone who understands what's going on with Tesla understands the importance of Optimus. And Elon gave us a little bit of an update, probably as much as he was comfortable doing that, but at the same time gave his kind of standard answer at the end. It's like, just imagine how big a market is that when you have a robot that's sentient and is able to understand and operate in the world. Then he gave a couple other few hints in there about why he thinks that they can scale, how they will be the ones to be able to do it, and some of the problems they think they have some unique solutions to. But it more or less says that we're on schedule, that they're going after the low-hanging fruit right now. So he said simple tasks. They're doing it in a laboratory setting, which I was sort of expecting they'd be experimenting more on the actual floor, but it sounds like they're probably able to take some of the tasks they're looking for and being able to duplicate them well enough in the laboratory. So this is an example of part of the laboratory. We're not seeing all of it because I think one of the videos they had, there was like a big curtain that was up that makes you imagine, there's probably more going on back there. So they're doing a lot of the training and learning for the bots here, understanding what their capabilities actually are. And clearly somewhere they've probably mocked up or set up some workstations to do what will be simple factory tasks. Now we've talked about some of these tasks in the past.
Yeah, let's do that. And we're going to show video of what they could be. And we're going to go right into the factories. This is in the lab. This was teleoperated. There's a human here off camera. But we saw that, there's workstations, workbenches, tables, right? And then there's 4680 batteries here and also behind as well. So, they're learning how to do this. And this particular demo was just to show, right, that the form factor of the humanoid bot is good enough that the hands and fingers are able to manipulate a shirt. If it can manipulate a shirt, it can do everything. But you can see that it's also testing this. So let's go right into Giga Shanghai. This is a video of Giga Shanghai. And tell us what we're seeing here.
Yeah, so this was a nice run through of this factory where we get to see some of the typical operations that a human operator is expected to do. And so this is a typical loading of parts into a robotic welding cell, something Elon had mentioned before. And you see you're picking up 2 simple pieces of sheet metal. You just have to drop them in a certain location. It's not difficult to do that. And then you have to push a button to let the robot know that the loading is complete and that you're out of the cell. And, he accidentally walked into the cell too early. So you see there's a safeguard and he has to reset the cell in order to make sure the robot completes that before he brings that piece in. Now, in the first case, you'll notice that he was able to grab 2 small pieces at the same time. In this case, the 2 pieces are a bit too big, so they decided they have to actually do it one at a time to bring it on in there. But that's done repetitively again and again and again. And you see some other examples of loading or possibly unloading parts in different stations. And they are very simple tasks. These are the low-hanging fruit that we've talked about that are repetitive and very easy, yet for some reason are really hard to automate. And part of the reason they're hard to automate is you see the robot is picking up a part to bring it over to the actual station where something is going on. So they want that part to be manipulated and brought over to the big robots, but you don't want the humans anywhere near that because there's stuff moving around and you don't want them to stop the operation. But in order for that robot to pick up that part, it has to be in a precise location, which is why they have those fixtures to drop them down to make sure that where the big robot can come and do it. Those parts come out of bins, and in the bins, all the parts are in there kind of in a messy order, and it's really tricky to just pick them up and pull them out. So it's a lot easier to pay a human being to do it than to create the automation cell, because if they could create the automation cell, they would have at that point. So what's happening, ironically, is the humans are being used to feed the robot, so that robot can then feed the actual cell. And that's something that would be very easy to replace with Optimus in there. And we'll see other, Now we see other examples going on here, which may or may not be that easy for the robot to do right away. Some of that might be just like inspection and going around. So some of these may be low hanging fruit. Some of them may be a little bit higher up and something that you'd have to wait a bit.
Less simple. Yeah, these are not the simple tasks.
It's less simple. Now, typically when you automate, you want to automate things that are like stiff and don't move on you, like sheet metal. When you start getting to these soft fabricy things, you know, it's a bit harder to automate. But we have seen Optimus is, able to fold a t-shirt. So it means like they are thinking beyond just the rigid objects that are very easy
here just for a second here, you can see and I thought I saw it, but there was this kind of like a blue plastic that the guy was managing. But okay, yeah. Or even pulling the plastic off of those before they go in. I mean, there's all sorts of operations that have to be done, and hundreds and hundreds of them that could be easily automated using a humanoid bot. And so this sounds like by the end of this year there will be limited use in production. And I'm pretty sure what meant was not like production of the bots, but actually being used in the production on the floor. Again, I keep on thinking it most likely is going to be the SX lines, because their volumes are a little bit lower and it might be less risky to try to implement in those lines. But I could be wrong. There were statements about the next vehicles, the new vehicles that are going to be running on the existing lines, and they should be getting a certain amount of efficiency out of that. And I wonder if part of that retooling of that is thinking about whether they would be able to do it with Optimus to help them drive those costs down. So they may be thinking a bit more about it. Yeah. So we're back to this scene again. And you're saying this is a simple task because they're grabbing a semi-rigid, a very rigid piece of material, and it's dangerous. And that's why it does actually have, you call it a cell, a kind of protective area. Now, at the beginning, Optimus can just go ahead and replace this guy. Totally. Just completely replace him. Just the way it is now, no need to change anything. But eventually, you're saying that eventually they could even redesign this and get rid of all of this.
Yeah.
It's not as big of a deal.
Yeah, rather than a human feeding a bot that then feeds the other bots, you just have the humanoid go directly to feeding that cell and get rid of that intermediate step. Also get rid of all these safeguards that you have there. You've got light fencing and everything else to be able to tell whether the operator is even close to that fixture, not next to fixture, but if he's even within a meter. So that light fencing is outside. And that's what we saw earlier, how easily it was for the operator to break it and it stopped. Because that's a safeguard, and he wasn't aware of that at the point. He thought that, I got plenty of time to get in there, or it's now time to go in there, and he didn't look up to see it. Well, wait a minute, you don't have the green light. You're not supposed to go in yet. And that's something, it's a kind of mistake that comes because, humans get exhausted. They're going to always make those little mistakes. The humanoid won't. The humanoid is going to know, I have to check. Right now, usually you're looking for a light that says it's clear, that you can go in, you can do the operation. And then when you come out, you also have to do something they call palm out. You've got to, hit something that says, yes, I have actually left the cell. I'm not in there right now. So it's kind of a safety clearance device. And then the other robot can go in there. So potentially you could speed those things up. But if you look at the operations, they're not really, really fast operations. The operator has extra time. I mean, he had so much extra time. That's why he jumped to the other cell too quickly. And he's doing two tasks. So he's able to manage two tasks. So if Optimus is too slow, you could put two Optimus there and to just do one task and the other task. the biggest concern we've pointed out is that you'll notice he's got to grab something and turn around and go and drop it off, turn around and come back. Is that most of the bots we've seen are really bad at pivoting right now, not just Optimus, but the others. And we've seen Optimus be able to do a curve, so we haven't really seen what Optimus is like walking away from something. But a lot of them have had sort of the difficulty being able to just kind of spin on a dime to get out. And that's what we have to find out is at what stage is Optimus right now? Is can it do the pirouette? Can it do a quick turnaround? Last week, Boss Dynamics showed their new Atlas robot being able to do it, and it does it in a very unorthodox way by using extended range of motion. Yeah, and it's very fast. And I know Optimus, kinematically the way it's designed, potentially it could also do that if it wanted to. The only reason maybe not is if the cables have to be adjusted a little bit to be able to have that range of motion. Yeah.
Clearly it can. I mean, if it really wanted to, it can just flip its whole body around.
Yes.
But it's not. They just haven't optimized for it. It's basically, I don't expect that to be a major issue. Let's take a look. Let's take a look at BMW's factory because, it's great to see Tesla's factory right in there. You can see that's fully automated. You got lots of humans still in the Tesla, but here in BMW, same thing, lots of humans. Yep. Look at all these humans everywhere. Probably it's safe to say that they have more humans. Now, in this case, this is not the kind of task like we were saying that they'll do right off the bat because this is not, this one maybe, but it's unlikely that they're going to be touching the car, right? There's still so much simple factory tasks, pick and place elsewhere outside of the car production line.
Could be, yes, exactly. They could. But again, you see there's also in final assembly, a lot of these operations that are fairly simple, just grabbing something from a shelf. So finding the item, bring it over, dropping it in, popping it into place, and then rinse and repeat. So, and all these things are already sort of semi-automated in a way that you still need the human to drive it in to locate it, but you have the equipment to automate lining everything up, also to make sure that the object that you're bringing is not too heavy. So a lot of times you need a lift assist or something like that. So again, the bots don't have to be super strong. They just have to have what is sort of the OSHA level lifting capacity. And again, these cells are designed for people of different sizes, and these bots, fit right into that class. So they would be able to do that without a doubt. And again, I mean, if there's an operation like doing that, that's not very hard to do. You can imagine the bot being able to do that.
So
again, ironically, it's so easy. It looks like, well, why can't they automate that right now? But it's just not worth the effort just to pop that little thing in.
And it looks like there's a lot of activities. And so if you bring in an industrial robot to do that one, it's dangerous. So you might now be able to do an industrial robot to do the wheels, but then the humanoid puts in the cap thing, and then there can be working Cobot, which is the whole point, right? But it's like a Cobot, actually, sorry, I'm using the wrong term. Cobot is when a human works side by side with a bot. In this case, it could be a humanoid bot working side by side with an industrial robot.
Yeah, a different
and
one.
You're saying you called it a dance, right? They can actually be connected to each other, and they will never be able to.
So you get a choreography going on, and it's well aware of what it's going to do, and knows like at this instant, you got to drop my head. So let everything go over. So it's going to look like one of those Abbott and Costello kind of sketches,
Yeah. Yep. So this is fun. When you and I got together over a year ago, we did our very first video together, and you actually pointed out we already know what the simple factory task is going to be because they revealed it on AI Day 2 or 2022. So let's watch that because you were the first to really just discuss this and talk about it. It's quite interesting what they said here.
Running as is, just retrained for the bot directly on that new platform. That's my watering can.
Yeah, when you see a rendered view, that's the robot. That's the world the robot sees. So it's very clearly identifying objects. Like this is the object it should picking it up. Yeah.
We use the same process
as we did for Autopilot to collect data and train neural networks that we then deploy on the robot. That's an example that illustrates the upper body a little bit more. Something that we'll try to nail down in a few months, over the next few months, I would say, to perfection.
This is really an actual station in the Fremont factory as well that it's working at.
Yep. So
did you catch the end of that?
Boom.
This is an actual station in the Fremont factory that it's working at. So they've been going out there and testing in the factory for
This was 2 years ago, Scott.
almost 2 years ago. Yeah. So probably, yeah. We're not quite in the sun, but it's pretty close. And so that's where they were doing initial testing to make sure the humanoid form would work, what the capabilities were, what some of the problem areas are. And already it was pretty advanced AI as far as being able to do a lot of the development, or let's say a lot of the identification of the objects and know what to pick up, how to do that. Still was probably a little bit of heuristic coding because I hadn't quite got all the end-to-end in there. But now that they've got end-to-end for full self-driving, I imagine they're doing the exact same thing now with Optimus, that they're a lot more end-to-end, because they talked about that about a year ago, that they had the first end-to-end training going and working for Optimus. And so now they're looking for more tasks. And there's probably other tasks like that in the factory that are fairly straightforward, that are just unloading something like that, as you can saw, and just creating a pallet of parts that are going to be used in another operation. I think that looks like it might be a bus bar or something like that for a battery pack, maybe for the semi, or maybe for one of the other sexy models. It's sort of hard to say.
It's not final assembly, but you're saying, they're creating something and you think it's the battery pack. And they just grab this and put it over there. And it's just a simple twist. You don't need to walk too far.
Mm-hmm. Yeah, and that, in many ways, that's designed to just use your torso. So you don't have to do the pitter-patter with your feet to try to move around, because it's just designed to load and unload that particular machine. And it could be one of those machines that is not like high volume. It just does a certain amount of production during the day, and then you're done, which is why they may have thought, oh, let's not even bother to automate it. Because in some cases, maybe you could have put a cobot in there to go ahead and do it. But if it's only running a couple of hours and then it's done, which is why they might have had access to it, it's just like, yeah, you can go ahead and play with this because it's not nonstop operation. But that's a good thing, because the whole idea of the humanoid bots is they are deployable, on-demand automation, whereas a lot of the other automation you have is very fixed. It's there. And if you're only getting an hour or two of operations, a shift per day, it's not worth it. It has to be something that's kind of nonstop. So it might do this, and when that's done, it goes over and unloads another machine and does another one after that, and you get a lot of utility out of it. So typically that's what they might be doing if they had a worker there, is that the worker does one task, moves to the next. And some of these may be tasks that are easy to kind of duplicate in the lab, but you don't need the full line in the lab. You can probably take some of the old fixturing you have and a pile of some components or parts, and then just keep on training Optimus over there. So what we saw in the Shanghai video there, you don't need that whole factory line. Again, you can duplicate that in a fairly small space just to train it and to understand what's going on without necessarily going down the line. And that's probably what Elon was talking about. They're doing in the laboratory, and it may be because it's easier to make sure people aren't taking pictures and reporting on what's going on. You can control the narrative a little bit more, as opposed to having it out in the factory where it's a semi-public setting, because remember, there's a lot of people that are going through there all the time.
So Scott, what we saw there, that was 2 years ago, AI Day 2, 2022. It's now 2024. This is Gen 2, right? That was Bumblebee, you called it?
The first one was Bumblebee, yep.
This one's even more, of course, refined. It's closer to design lock if it isn't already. It's got even finger sensors, as we'll see here shortly. And they've showed that it can actually fold clothes. So, you know what I mean? Like, if they were able to show that already in 2022 with the ability to grab a bar, but now look at the finger dexterity that we have now. Now that we have finger sensors now too, maybe the kinds of simple factory tasks might be able to be expanded beyond this as well.
Yes. So the bot we're seeing here is way beyond the bot that you would need to do that operation. As we can see, they were able to do it very easily with what was just kind of the original mock-up they were working on. And this here is a much more refined robot that can do more tasks, more delicate tasks, tasks that could require a lot more dexterity. And so that means they're thinking more than just the low-hanging fruit, but also looking more complicated tasks. Probably eventually they like to get into final assembly. Doesn't mean that that's going to be there at the end of the year, but it means they want to make sure that they have a bot that they know physically has that capability, even if they haven't got the software training set quite up there yet. And it could be that there's also some things they need to improve on the speed to be able to get the functionality they want. And that's something we've talked about.
Yeah. I mean, so they've shown that they can teach it. This is via teleoperation or even just watching a video. They can then replicate the task. And especially if it's a simple task, then that's something that they feel comfortable saying that. That's why they can say, right? That's why they can say that we're going to be able to have this. It's doing simple tasks in the lab right now. We're going to do it in a factory by the end of this year. What's the difference between that? Like, why is it that it'll take the end of the year? It's probably speed, right?
I think it's speed. I think it's speed and reliability. So they can demonstrate that it can do these tasks, and then they can probably bring it down there, and it may function well for 5 minutes or 10 minutes, or maybe it's just a bit too slow. It's like, oh, it can do it, but it's not quite keeping up the line. So they are probably in the lab right now seeing what can we do to improve the speed. Now, you've got to be very careful. One way to improve the speed is that you can just run your motors at higher power, but then that means you get faster battery drain and it doesn't last as long. So there's that delicate balance between how do we get more speed out of the system without drawing too much. And there's a couple of places that your energy gets used up. One is the actual motion of the actuators, and the other is the compute that's going on. And there's a lot of compute going on in the control system, and actually in the actuators, there's also cards in there. And we know from having talked with an engineer from another robotics company that their initial run, they found out that they were using more energy in their control cards than they were actually in the actuators themselves. And they needed to find a way to clean that up. Now, there was a comment that Elon made that was rather interesting when he talked about it. One was, not just the production and scale, but if you can play that.
No, I've got the comment of what he said at the earnings call.
Okay, yeah. If you get the quote. Yeah.
I don't have, I'll just give you the quote. It's, he said, Optimus will be more valuable than anything else combined. Sentient humanoids navigating reality and doing tasks. There's no limit to the size of the economy. And then they said, Tesla's best position of any robot maker to make sufficient production with efficient inference in the robot itself. Tesla's inference efficiency is vastly better. He keeps repeating this, which is the chip that's in the bot or the chip that's in the car. The inference, that's an inference chip, not just the training compute. So NVIDIA is obviously the leader, or currently the leader in the best training compute. But the inference compute, which is the one that actually does the task, is so efficient in the cars and bot that he talks about it, meaning that it doesn't take up as much energy, right? So he is saying that this is an important thing. That people are not even talking about it, that it's going to be critical. What's your thoughts on that?
Yeah, it's very critical, because if you've ever seen some of the early days of self-driving cars, the experimental cars that are out there, there's like a lot of computers, and of course you get the LiDAR and everything else, and they're consuming a lot of power just to figure out how to go. And you've got to remember that Tesla's an EV company, and they're thinking about, oh yeah, we're going to have autonomous driving and everything else. And if you come in there and find out, yeah, but if you do that, suddenly your range is going to be cut in half because the compute is just like using up everything. Then you're like, wait a minute, that's just not going to work. We've got to make sure it's very, very, very small. So they worked a lot on their inference to be able to make sure it's very, very efficient. And that's why he's pointing out a couple of times there that a lot of inference for little, because your energy budget is really small. So they've talked about that the maximum power usage that they want to have is 500 watts. Okay, so let's put 500 watts in context. In the old days, remember the Edison bulbs, or like the brightest bulb you had there was about a 100-watt bulb. So it's like 5 of those. But the other way to look at it is that your blow dryer, hair dryer, can output 1,500 watts. So in other words, the energy budget is just 1/3 of that, 500 watts. But still, like with a blow dryer, I mean, that's using up a lot of energy. And if you run it for an hour or so, you're using up an awful lot of electricity. And so if you are at 500 watts and let's say your compute's taking 300, that doesn't leave a whole lot for your actuators to be doing anything if that's the maximum that you want to have. So my understanding is that the compute they have is under 100 watts. It might be in the order of 75 watts or something like that to be able to operate it. And that means everything else can then go to the actuators. That's quite important, because you've got a 2.3 kilowatt hour battery pack And if it's at 500 watts, you've got a little over, I think like 4.5 hours of operation maximum. And you'd like to make it through an 8-hour shift. So you make it through an 8-hour shift by making sure that you're not going at 500, you're going less than that. So if you're already wasting 200 or more on your inference, then it's going to be really hard to make that 800 or that 8 hours. So you want the efficiency there. And remember, they're obsessed by this in Tesla. It was always about range. So that's why you design the car to have a low drag profile. You come up with efficient powertrains. You come up with a heat pump and everything else in there because you just don't want to waste power on things that you don't have to. Obviously, why the lightings are all LED lighting because it doesn't require a whole lot of power to run. So they're obsessed about power and making sure you don't use too much of it. And that's carried over to the bot design because fortunately, we get this inference chip, which is already really, really efficient. And I don't know if he's sort of implying that the inference chip that people are going to be getting from NVIDIA might require actually a lot of power, which is possible because you think about it is NVIDIA, are they optimizing right now for the inference chips that are going to humanoid bots? I think they have like a generic chip that everyone's using for their inference for their servers. And while everyone's like a little bit concerned about the amount of energy these things are going to use, they're not quite as concerned about it being really, really low level like that. So if your inference chips is just going to be plugged to the grid, you're not quite as worried about energy conservation as you are when it's actually plugged into a battery pack. And remember, Tesla's got one of the bigger battery packs probably of these bots. These others might have like only over a kilowatt hour or something like that. So they're going to have a hard time getting just past 2 hours.
Yeah, this is where it's all coming together very, very brilliantly, right? So Tesla is, and I'm going to show you the table here, is a battery company.
Yes.
And so they're going to be better batteries, hopefully, likely, very likely than everyone else. They have the inference chip, which is designed because they had to do it for the cars to be low power efficiency required, which again, NVIDIA chips weren't designed to do that. So all the other bots will have that. And so when you have, the ability to make maximum use of your bot, like you said, 8 hours instead of 6 hours, maybe you can also have smaller batteries and therefore lighter and less cost, number one, but also lighter. So that's more safer to work with with humans. So let me show this, which is a table that they showed at the shareholder deck at the earnings call, and they talked about that. The Tesla ecosystem is more than just vehicles, and this is all the things that Tesla's doing. And of course, the one part is the humanoid bots, but they're using AI compute. And then, of course, the FSD, and then the batteries. So that's my point. That because this is one company that's doing batteries, that is doing the AI compute themselves, whether they buy it from NVIDIA or their dojo, but they obviously are, of course, leaders in AI and data centers. That's what they're doing for humanoid bots. And so if you look at any other humanoid bot companies right now, the knee-jerk reaction by all of us is that the one difference between Tesla and all the others is the ability to scale, because Tesla's got factories and knows how to do this, but they're also not considering the batteries, the AI compute, the inference chips, and all the AI training that they're doing for FSD is being all reused.
All of it. Yes. So they'll have very efficient batteries. Batteries will be almost like zero cost as far as Optimus is concerned. And, the battery management system that goes in there also, I mean, all these things are going to be very low cost items when it comes to Optimus, because it's just something that Tesla is already building at scale. And they're really good at reusing a lot of the technologies they have. The surprising thing is that the inverters that are inside of your Tesla car to take the AC that's coming from your house and convert it into DC that goes into the batteries, they just stack those things together at the superchargers. That's what's in there. It's not like it's something new. It's just like, well, all I have to do is stack these together. And from that, we can get the requirement is and say, wow, then why don't you just put it in the Tesla? It's like, because you don't feel like putting that big stack in there. You just put a little bit of that in there just so you can charge at home. But when you really want to do something else, it's better to have that thing offloaded and put that on there. So again, they're reusing a lot of the technology. Now they might slim it down because they don't need to have 2 FSD chips on there. They can have one and a few other things. But for the most part, they're taking the existing things that they know how to produce and just repurposing it. And again, when it comes to the FSD, is they didn't talk too much about Optimus and the training on Optimus, but we learned a little bit by listening to a shock, because everyone wanted to know a little bit more about how FSD was going and how that was going on. And one of the first things, and they asked about how much compute they have, and I think they said they have something like 35,000 H1 compute. Well,
H100s.
Elon didn't know what to call them, like CPUs or GPUs, because it's like, technically they're not really GPUs, they're more for the training. But he said by the end of the year, they'll have 85,000. So it's like, holy cow, they're adding another 50,000 on top of that. And it seems right now, he said they're not compute constrained. And we're seeing that because every 2 weeks we're getting a new rollout of version 12. And so it means something is definitely going on pretty quickly there. And if they get it up to there, that means they got more than enough for this Optimus side project to be able to have the compute it needs, as well as the other resources. Because one of the things that they've talked about is that it seems they have almost like a much bigger model that they're using right now for the inference in what they call the much higher fidelity simulator to test things out. So they can really test out in like a simulated environment what the car is doing. So they're already being able to create a good physics model. They don't have to go anywhere else for it. And that's probably the same model they can also use for Optimus. And from that, they're figuring out how to scale that thing down to fit onto the chip. And so there is a way of doing it. And that's what they're trying to figure out. So they're already seeing that. I'm pretty confident they think they've solved full self-driving. Well, right now, what they're trying to do is figure out how we actually get it to fit in the chip. And if they've really solved this, like for the most part, they've solved it for Optimus too, and they have the compute. So my expectation is that, they will have a pretty clever bot that, as he said, these sentient beings, they're able to go around and operate in the real world very, very quickly. And I heard a joke the other day is like, what's the difference between AGI and ASI? So artificial general intelligence and artificial sentient intelligence. Do you know what the difference is?
I don't.
1 year.
I love it. Beautiful. The thing about the data compute, going back to Tesla's, because they need it for the cars, is they need all the videos. In this case, we're grabbing videos of cars driving through city scenes, streets. Now they're going to need videos of humans walking around shopping malls, houses, offices, indoors, that you don't have those videos. And then it will recognize what a Coke can is, what a fridge is, how to open that particular fridge, how to open that particular door, pull, push, read the side, understand, right? But if you feed it enough videos, it will know. And that's what they need. They need big enough computes to be able to feed it more videos. Yeah. So there was a small Easter egg in this video that we were watching earlier. And it's that these over here, I don't know if you guys can see this, it's a little on the other table here, not the table where he's folding it, but you can see there's a stack of 4680 battery cells. And it could be that it's just easy to grab and hold, but is that an Easter egg? Could these bots be having 4680 cells, or they don't need it?
I don't think, it's possible that it's a Gen 2, they redesigned it a little bit. The first one I know was 2170s. So we were able to see that, and we know the exact number. It was 180. 140 that were in there. It's possible because the chest cavity is a little bit different. That maybe my feeling is they probably not, because you want to reserve those for the Cybertruck right now.
But the question is, Scott, it's not whether or not the bot is using it, but maybe the bot is going to be doing a task associated with these. And you said no, right? Because that's something that you can very automate.
Because that's already highly automated. I've already seen the lines that they have for stuff like that. And it is already automated with the traditional robots to be able to take them, sort through them, do the quality control with them, corral them together, make sure they're right. There's a lot of automation there, and then they pick them up and they put them in the modules. So they have a lot of those things, and they can do them a lot quicker than you can with a bot. So these robots will go over and they'll pick up like 130 at a time, and then just be able to do a quick scan of them to be able to see what the quality is in, because they end up going through a testing station, and then from that they know which ones, and they can pull the good ones out and the bad ones out. So a lot of that's already heavily automated. So that's why I don't think there's something going on there, unless there's some other aspect that's going on that needs to be manually done. But yeah, I think all of that the welding and everything. You see how they weld the tabs on there. Basically they kind of put it in there and like one shot, and the lasers come down, all the tabs are down in one. So it's not like someone going around and welding everything one at a time.
Okay, well, thank you so much, Scott. That was fun. We showed videos of the actual factory in Fremont that, AI Day 2, they actually showed. This is an example of a bot in the actual factory. Now they're saying that they can actually have a small number, but I think the difference was with that one in AI Day 2022 was just to proof of concept, to just show you. But now it's actually, when they say that they're going to have a bot in the factory by the end of this year, they're talking about replacing a human, like actually working, like a hired, right, with a badge.
Exactly.
Get their coffee breaks so that they can get charged.
that's the difference. And, and I'm assuming that what happened in that station in Fremont is those parts weren't just chucked out. They ended up going somewhere. So they're in a Tesla vehicle somewhere, right? And it's just that
somebody has
done the whole shift. And we talked about that before, is that, it has to do useful work. So like you say, it needs to be able to go in, do the badge, be fast enough to be able to keep up with the humans, be able to last the whole shift, and then be able to come around, do the next thing and do it, close to error-free, if not error-free.
Yeah. So by the end of this year, there's already going to be Tesla bots in a factory. Yeah. Hopefully that's what that means. Next year, they're going to sell it. So I'm telling you that this is crazy time frame. Even I and you, people accuse us of being such optimists. We both thought that they would make 1,000 bots, 2,000 bots, use it internally. And then we thought, okay, after use it internally, you're going to, maybe sell it or use it for your suppliers. But for them to now say they're going to sell it, that means, again, hopefully I'm not overthinking this, but it can't just mean I've made 500 bots, I'm not going to use any, I'm going to sell 400 and I'll keep 100. No, it's like I'm most likely going to make 1,000, maybe even 2,000 for myself, Tesla, and then I might make 1,000 that I'm going to sell. It could also mean just a small number, just to prove that I've got customers buying it, it's a product and they're buying it. So that one I don't want to jump too far on, but it's still amazing milestone.
Yeah, we didn't quite have it on there because we felt that it would be a while for them to reach their internal demand.
Yeah.
And they said sell. I was like, okay, do you really mean sell or do you mean lease? Because I'm pretty sure it's going to be kind of a lease model instead.
It's a lease, yeah.
And the other thing is that I think you need to satisfy your internal demand first before you start selling it externally. And then, so that must mean that they're going to have enough to sort of fit the needs that they need before they say, oh, okay, it's worth putting it out there. Or maybe that they want to do a little bit of a balance because, they can get.
It's also non-zero chance. It's dare for us to dream that this is a design lock, that they're actually going to have it in their factories this year, which means that they're using it and proving that it works. And we're talking about mass production next year, like mass production. That's what it has to be mass thousands. Production. Because other companies, they might only make 100 this year, 1,000 next year, 10,000 the following year. Tesla does not need to do that because they have the ability to make tens of thousands as soon as they want to.
And it could be if they get the line that's sort of up to meet their internal demand, because they do want to get a certain number of bots out there. They're going to want to keep that line running, and then they may be getting an oversupply and say, these are way more bots than we can absorb right now. Yeah. So let's start sending it to like our tier suppliers and other customers, potential future ones, let them start working with it. Now, Elon said he hedged it a little bit to say it's not a sure thing. For that to happen, there has to be a certain degree of confidence that when it gets in customer hands, they will actually be able to do something with it and not have like a disaster scenario. So they probably need to go through that, but it seems like they are confident they probably would be able to do that. And let's say that's sooner than I expected, that part for sure.
Okay, cool. And then I keep reminding people that there was it might have been a one of these shareholder day meetings where Tom Jew was up there, and he said, Giga Mexico, think about what happens if I have 5,000 humans and 5,000 Optimus. So that was indication that they're thinking 5,000 in a factory.
And when you start designing the factory, you want to be thinking about the kinds of resources that are available and also upcoming resources to make sure you are kind of future proof and don't design for something that's like, oh, wait a minute, we get something new that's coming in here. So I'm pretty sure they're looking at the entire process on how Optimus could be used more efficiently. And that might mean, like we say, getting rid of certain safety fencing, because now it's allowed to go in these particular zones that you would not send a human being into. And there may also be some things that it can't quite do as well as a human being. So you redesign the product to make it more accessible. And we do that already to make it easier on people to be able to build a product. So they might be taking the same approach also with Optimus.
Okay, listen to this, okay? Hold on.
So what it takes to ramp a Gigafactory? Well, if you have 600 robots, 10,000 trained employees, or 5,000 human and 5,000 Optimus, and hundreds of processes, you can do it. Sounds simple, but it's extremely hard. So there's two key metrics that we predominantly focus on. It is the overall equipment effectiveness and the cycle time. In Tesla, we're setting the passing grade for our vehicle factories.
Yeah. Did you hear that?
Yes. He said definitely the 5,000.
Okay.
Those are the kind of numbers they're looking at for a factory. Yeah.
For a factory. Okay, that just gives you a sense of how many bots are needed in a factory.
Yeah.
5,000.
Mm-hmm.
Anyways, great show today. Thank you so much, Scott. That was great. That particular film we saw in AI Day 2022, where you can actually see a bot in Fremont, an actual Fremont location. That's very likely what it could be done. Simple tasks. That's what he means. Thank you so much, Scott. That was fun. Appreciate you.
Yeah. Thank you, Herbert.
Bye-bye. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.